Now we're going to gently introduce just a little bit of arithmetic. And a little bit of arithmetic to related to the toolkit scoring function. There's a formula for the function. So what I'm going to do first, I'm going to construct the graph. You're going to construct it without comment. You can time me. I'm going to do it at a leisurely pace. Should take me over about a minute, but I don't want to rush, mainly because I'm not sure I can muster up enough coordination to rush that way. To rust, yeah, rust, to rush. Okay, here we go. I missed that point by a mile, but so be it. Okay, so that didn't take long. It's not particularly well done. I thought it was going to come out better than that. But it's a little asymmetric, it's a little lopsided or something. Okay, still, there's our graph. Now, if I've done the graph correctly, and if I insert the x-axis through the red dot and a y-axis through the red dot, then I can figure out what the coordinates of all these points ought to be. Okay. For example, if this is 4 units here, then this is 2 units, and this is 1 unit. Similarly, because here is 2 units, compared to here is 1 unit. Compared to here is 1 unit. Compared to here is 2 units. 2 and 2 makes 4. Red dots in the middle. So this point has to be 2 units to the left. This point has to be 2 units to the right of the red dot. This point has to be 4 units above the red dot. This point is 1 unit above the red dot. How far is this point above the red dot? Well, you should figure that out. Okay. This means that the coordinates of this point, say this point, have to be one. The x value is 1 because the vertical line through the point hits the x-axis 1 unit to the right of the origin. And the horizontal line through the point hits the y-axis 1 unit above the origin. So the point is 1, 1. Now, I think everybody should be very familiar with that, but if not, that's really how we do a set of coordinate axes. So what do you think the coordinates of this point, this point, and this point? You should stop and jot it down. If you're wrong, you are the only one that's going to know about it, and you're going to learn something by being wrong and figuring out how to correct yourself. Coordinates, it should be pretty obvious, just in case. Okay, I'll list the coordinates here. X coordinate is 2, the y coordinate is 4. Horizontal line through this point goes through the y-axis 4 units above the origin. The vertical line through the x-axis 2 units to the right of the origin. This point would be, I have a good place to lay it. If we're 1 unit to the left of the origin, well, that would be at x equals -1. And this point would be at -2. Okay. Now, I'm going to give you the formula. For this graph. It's y equals x squared. Now let's check. X equals 2, y equals 2 squared, because we replace x by 2, we get 2 squared, right? Which is 4. 2 times 2 is 4. So the 0.24 is correct. What if x equals -1? Now, I wrote y equals -1 with a square on it. That's not correct. This says we square -1, and if we're going to square -1, -1 has to be in parentheses. So if you put it into your calculator, like just a negative sign and a 1 and a square, it's going to give you -1. But if you square -1, that means -1 times -1. Negative times a negative is a positive. 1 times 1 is 1. So according to our construction, all these points work. Now, I'm not going to check all of them. You got to check out 1, 1. If you put in 1 for x, you get 1 for y. I find that you will. If you put -2 in for x, you get 4 for y. Put the calculator out of your hands. Do not use a calculator to do 2 times 2. Use the calculator to do the square root of 79 if you want to, okay? That's fine, that's valid. Don't use a calculator to do the square root of 64. If you don't know that the square root of 64 is 8, you don't know your arithmetic well enough to understand functions. And you don't need to know that 16 times 16 is 256, although it's kind of a good thing to know. But you do need to know your single digit multiplication tables. And you need to know what. Put the calculator out of your hands. Okay, so that's it. Now we've kind of verified the formula. We can even do a little better than that. Now this is something that you might end up using your calculator for. Let's say that x is 1.5. Now where would 1.5 be? Well, here's 1, so here's 1.5. So I can even draw a vertical line here and say that this is a line x equals 1.5. Where does that vertical line intersect the graph? Well, I told you that my graph wasn't very accurate, and I'm going to prove it because we're going to get a bad estimate. If x equals 1.5, according to this graph, what's the y coordinate here? What looks like y coordinate might be just a little higher than this dotted line. Okay, you see this dotted line here is the line where y equals 2. Okay, there's 4, there's 2. Every point on this line, y equals 2. It looks like this point here is 1.5, 2. Let's check this. I'm running out of room here. X is 1.5, and Y would be 1.5 squared. Now you shouldn't have to use a calculator to figure that out. One and a half is 3 halves. Yes, you have to be able to do fractions. Okay, 3 halves squared is, I'm just going to write it out, we'll do more explanation. It's 9/4, which is 2 1/4, not 2. So graphical estimate 1.5, 2, not right. This could mean one of two things. One of the things it could mean is that I lied to you, and this graph isn't a good way to construct a squaring function. Okay, well, I didn't lie to you. It is a good way. You'll have to check that out yourself. One other little aspect. If you go to negative 1.5, that would be like here. Okay. Now, if we take this point on the graph and come over here, we're higher than we are here, so our estimate would be a little bit higher. Actually, the estimate there would be probably close to 2.4 instead of 2 1/4. So you don't need to know all that. The point is, once you have these graphs and do them carefully, you can make impressively accurate estimates of the values of these functions. They might ask, why is that important? Well, it's important so you internalize the meaning of the graph. And then you can think about things that you would not otherwise be able to think about. So we do a lot of this estimate. You're going to be asked to construct graphs and make a lot of estimates. And these are estimates that you would not be able to do. You'd not be able to figure these things out easily without a calculator, and you wouldn't want to do it anyhow. You want to do estimates, you want to do them accurately. Well, more about that in the future. But again, understand that come into class after we talked a little bit more about estimates. I ask you to sketch a graph and do an estimate. I'm not going to give you time to figure it out with arithmetic. I'm not going to let you use a calculator. You have to do an honest estimate. Then we can check the estimates. I'm not going to penalize you for making a bad estimate unless it's ridiculous, but we have to be able to do these things. Okay, so you should prepare yourself at this point. You should prepare yourself by learning to make reasonably accurate graphs. And it feels kind of good. You do a reasonably accurate graph, make a good estimate, and later check it out on your calculator, find out you did pretty well. And almost everybody is going to do pretty well on that, just a little bit of practice. It's not difficult. We'll explain it more later.